Hi, Mrs. Young here. This is lesson 3 of our revolving and cross-section unit, short unit. This hopefully should be a short lesson today. I want you to have 3 things up for me. The homework from yesterday. I know that I've been just emailing you the homework answers, but this time I'm actually going to take some time to go over the homework answers from yesterday with you, make sure that you understand. And also have out your spiral for taking some notes. And also make sure that you are have a tab open to that Transmographer website that we were looking at yesterday. I really like this website. Here it is. So make sure that you go to that, remember shodor.org, whatever, and then go to the 3D Transmographer website. Maybe have that tab open and handy for you as we go through today's lesson, because we're going to go back and revisit this. So have out your homework, have out your spiral, maybe have a tab open to that 3D Transmographer website. I'm going to pause it, or you can pause it for just a second and get yourself ready. So I'm going to start by going over your homework answers from yesterday, from day 2. We were taking 2D shapes, revolving them to create 3D shapes, kind of just checking your answers here. You needed to sketch it and give me a description. So the first one, obviously, when you rotate it, it becomes a cone. Their sketch, this person did it right on that line of rotation. Maybe you drew yours over to the side, that's fine too. Letter B, obviously the rectangle revolves to become a cylinder. Letter C, the half circle revolves to become a sphere. I wanted to talk about D for a second. When you have a circle and you rotate it around, and if your line of rotation is not going through the circle, there's going to be an opening here in the middle. So if you think of it, like to you, that's called a donut. But in math terms, in the math world, we call this a torus. T-O-R-U-S, torus. Maybe I can jump to, I think I pulled up, here we go, a picture of a torus to show you. This is if you take a circle and revolve it or rotate it around a line of revolution that does not go through the actual circle. So that's called a torus, and there's a whole bunch of, like, if you know, I just went to Wikipedia, all the math about it. There's like a minor radius and a major radius, and honestly, I don't think I learned the volume of a torus till I was in Calc 3. I think, I can't remember. But again, that's much more advanced, but I just want you guys to be aware of and comfortable with that term. So I'd like you to use that term torus, but in your mind, you can think, oh, that's like a donut shape. Letter E, this rectangle, again, I don't know why this guy called it a toilet paper roll. I want you to say it's a cylinder with a hole drilled out of the middle, cut out of the middle. So again, it's a cylinder shape with, you could even say like a cylinder cut out of the middle. Letter F, this would become a sphere with, he says, with the core gone, or you could say with a hollow sphere in the middle. It's almost like a jelly-filled donut without any jelly in it. Letter G, when I revolve this, I create a cone on top of a cylinder. So a cone on top of a cylinder. Letter H, to me, this one is like an upside down cone with a cone cut out of the top, right? So it's a cone with a cone carved out or missing from the top. In number 2, you're working backwards. So the 2D shape that came from. Letter B, the 2D shape that this came from. One thing I want to point out to you, and I don't know if I mentioned this in the lesson 2 video, we've got spheres and cylinders and cones, but notice that you do not have any prisms or pyramids, because when you rotate, revolve this shape, you're never going to create something with like a square base. So you're not going to have prisms or pyramids. On the second page of your homework, they kind of give the analogy of a pottery wheel, right, that revolves or spins around. So again, working backwards, this is the shape before, the 2D shape before they revolve it. The middle one, here's the 2D shape before, and then letter C. I don't know how good, yeah, this one is a little, I think that last one's a little off, but that's okay, not bad. In number 4, again, this person who made this answer key obviously is not that good of a drawer, because here's mine in the middle. Kind of proud of myself. If I took that 2D shape and revolved it, I would get that shape, which is kind of like a vase. And then the one down here in B, again, if you revolve it, you get kind of like a cup shape, right? So again, those are just some examples of what your homework should have looked like. So go ahead and take a minute to check over your homework, and then we're going to jump into our lesson for today. Again, we're going to be going to that 3D Transmographer website. Again, you're going to make sure it's defaulting to 4 vertices and click go. And I want you to type in these 4 vertices. And then you're going to click graph. It'll create some type of quadrilateral. Then you're going to, down at the bottom, make sure that you're revolving around x equals 0. That's real important because I think it defaults to y equals 0. So make sure you have it revolving around x equals 0. And then in your graphing spiral, you're going to graph the quadrilateral that those 4 points make on a coordinate grid. Then you're going to sketch what your 3D shape looks like, kind of like you did in your homework. You're going to describe what that 3D shape looks like to me, like you did in your homework. And then I want you to find the volume of that 3D shape. So again, you're going to create the 2D shape, sketch a 3D shape, describe the 3D shape, and find the volume of the 3D shape. So I would say pause your video here and go ahead and enter this into your Transmographer website and make sure you complete all 4 of those pieces of the problem. Let's go ahead and pause it and take your time and work on this problem. So on your 3D Transmographer website, again, I tried to pick some easy vertices for you to enter. This is what your 2D shape should look like. You should have selected to reflect it or revolve it across the x-axis. Yeah, you can just leave it medium and go ahead and revolve it. And you can see, hopefully, that you created a cone on top of a cylinder, right? A cone on top of a cylinder. So back in your spiral, back to your problem that you were working on, there were 4 things that I was looking for. First, you should have the shape graphed in the coordinate plane. Then you should have a sketch of what the 3D shape looks like. You should have described it to me. I just said a cone on top of a cylinder. You could have been more specific. And then finally, you had to find the volume. So the volume of the cylinder that has a height of 6 and a radius of 6, that's 216 pi. The volume of the cone, 1/3 pi r squared h, has a radius of 6 and a height of 2. So that volume of the cone is 24 pi. When I add the 2 pieces together, I get a total volume of 240 pi. So double check and make sure you got that answer. Again, 4 pieces to this problem. Drawing it in the coordinate plane, giving me the 3D sketch, describing your 3D sketch, and finding the volume. So take a minute, maybe pause it and double check your answer. Okay, so we're going to continue kind of the same problem. So we're not going to have to sketch this shape again in the coordinate plane. We already have it. But this time, I want you to go back to the Transmographer website. Instead of revolving it around, before we did x is 0, now you're going to revolve around x equals 6. Again, in your mind, before you even go there, think, what does the line x equals 6 look like? At this point, you should be able to predict what this 3D shape should look like. Then I want you to sketch that 3D shape. Again, describe it to me in words and find the volume. Again, using the 3D Transmographer website to help you, unless you don't need to. Again, some people maybe could even do this without that website, right? But maybe check it out, try it out. So again, pause the video, go to the website to revolve around x equals 3, sketch that 3D shape, describe it to me, and find the volume. So go ahead and pause the video and work on this. So you can see, again, we started with that same quadrilateral that we had from before, but by revolving around something different, you should know that x equals 6, x equals some number is a vertical line, x equals 6 on the x-axis, you go to 6, right? And you draw a vertical line through that point. So you know when you revolve that around, right, you're going to create this giant cylinder here that's going to have a cone cut out of the top. So again, there's my sketch over here to the left, not the best sketch for me, sorry. Describing it, I said that it's a cylinder with a cone removed from the top. And then to find the volume, the cylinder is pi r squared h, that's 288 pi. The cone cut out of the top is actually the same size as the cone that we added on in the last problem, that's 24 pi. So if you take 288 pi minus 24 pi, you're going to get 264 pi. Again, that's units cubed. So again, we're just using that Transmographer website to kind of help us out with this. You should be able to take any 2D shape in the coordinate plane and figure out what the 3D shape would look like based on what it's revolved around. Again, if you just change the line of revolution, that line of rotation, it's going to completely change what the 3D shape looks like. So make sure you remember what the horizontal and vertical lines look like. Again, if you play around with the website, you could even revolve it around a line going at an angle. We're not going to make you do that here in this unit. I'm going to strictly keep it to horizontal and vertical lines. Okay. So that's our lesson kind of today, was just kind of going over that Transmographer website one more and talking about this concept, which is what we will be assessing on. Can you take the 2D shape, visualize what the 3D shape looks like, describe it to me, and find the volume? So going to our homework, I'm just going to take a quick second here to pull up what the homework looks like for you. There's actually 3 pages to it. Ideally, you could print it out and do the work right on here and submit it that way. If that doesn't work for you, if you don't have a printer, that's fine. I'm going to show you, like on the first 2 pages, what you're trying to do here is match the 2D cross section. Oh, it's having me right on this. Shoot, I don't want to. You're trying to match the 2D cross section with the 3D solid on the next page. So like in this first example, here I'm looking at number 1. We have this little rectangle, and this line here is your line of rotation. So if I revolve that rectangle around that line, I know I'm going to create a cylinder that does not have an opening in the middle. Kind of like this one, but maybe a little bit bigger, right? Again, whereas you can see number 2, there'll be some kind of opening in the middle. So if I look at that number 1 graph and then go to the second page, which one would it match up to? Again, I want a cylinder. But I can't be V because I don't want there to be an opening in the middle. So I'm going to say S. So again, if you don't have a printer, what you could do is just write down on your paper 1S, because you're matching the 2D shape with the 3D shape. So you'd have to scroll back and forth and then write down your answers on a separate sheet of paper, which you could very easily do. I'm a big visual learner, though. I'd probably like to print this out if I could. And then the third page or final page of the homework, they're giving you 3 different views of a 3D shape, and you're working backwards to create the 2D cross section. What would that 2D cross section look like? I think there's only 1, 2, 3, 5 of these. And again, if you don't have a printer, you could just graph this on a little bit of graph paper that you have. Again, you're just trying to draw in what it would look like as a 2D. I'm going to try to guess on this one just to show you, like, as an example. I don't know. Oh, well, okay, cancel that. My pen is not working good. This is on this is on a Word document. Oh, so again, you could just sketch your oh man, you could just sketch your 2D right here on the grid. If you don't have a printer, just do it in your spiral. So that is my video for today. Sorry, I messed up on my homework. And check back with me tomorrow. Bye, guys. Thanks.